Firstly, today we're looking at a review of what we learned yesterday. So before I do each question in the video, I'd like you to pause and attempt the question yourself in your copy and see can you remember how to do it. So the first question I have to deal with here is one where I have to look at a bit of addition, okay? So x plus 4 is equal to 9. So we learned yesterday that if I have an equation, I want x's on one side of the equation and I want the numbers on the other side. So now I have x plus 4 on one side of the equation and 9 on the other. Well, what I'll want to do is I'll want to take away 4 from this side, and I'll also want to take away 4 from the other side of the equation. That will then leave me with x plus 4 minus 4. So x plus 4 minus 4, well, if I have 4 things and I take 4 away, I'll be left at 0, is equal to 9 take away 4. That will leave me with 5. So that leaves me with the answer of x is equal to 5. Now, don't let me forget the arrows. Now, what I forgot to mention in yesterday's video is there's a way we can check our answer in these algebra questions. That involves substitution, where we take our answer and we substitute it back into the original question. So in this case, our original question was x plus 4 is equal to 9. Well, we want to substitute, which means replace the x with the 5, which was our answer. So x gets replaced by 5. Then we'll have 5 plus 4 is 9 is equal to 9. Is 9 equal to 9? Yes, that's true. So that means we have question 1 done correctly. Then we can look at our next question, which has 7 minus 3 is equal to minus 7. So what we can do here is much the same as before. We'll start off our question by saying z minus 3 is equal to minus 7. I have minus 3 being taken away on this left-hand side. So if I add a 3 to the left-hand side, I'll have to add 3 to the right-hand side as well. But if I add 3 to the left-hand side there, then I will end up with z minus 3 plus 3, which will cancel and give me 0, is equal to minus 7 plus 3. So negative 7, and I add positive 3 to it, will bring me to negative 4. So then I have z is equal to negative 4. Now I can check my answer just like before. So I have z minus 3 is equal to minus 7. And I'll check my answer by replacing z with minus 4 and seeing what I get. So now I have minus 4 minus 3 is equal to minus 7. Well, if I have negative 4, I take away another 3, I'll end up with negative 7. So negative 7 is equal to negative 7. That's true, so we know that that means we've done the question correctly and we've solved it correctly. Next up, we have the ones that are going to involve they're going to involve multiplication and division. So now I just noticed a small mistake I made here, so I'm going to have to change this question, but we'll do the first one first of all. So we have minus 3b is equal to 9. So if I want to solve this one, well, first off, I want to make this positive, so I'll change that to plus 3b. But if I change the sign of one thing, I'll have to change the sign of every single thing. So now I have plus 3b is equal to negative 9. Then what I can do is I can say, well, I have 3b's is equal to negative 9, and I want to divide that by the number in front of b. So I'm dividing 3b by 3, and I'll have to divide the other side by the same thing. Because any operation I do to one number in an equation, I'll have to do to every single number in the equation. Or if I take away from one side of the equation, I'll have to take away from the other. So I have 3b divided by 3 will leave me with just a b. And then I have minus 9 divided by 3 will leave me with a minus 3. So now I'll have to check that answer. I have minus 3b is equal to 9. Minus 3 times minus 3 is equal to 9. So that's a negative number multiplied by another negative number will give me a positive number, and 3 3's are 9. So plus 9 is equal to 9. Yes, that's true, so that's perfect as well. So let's say I take another one where I'll have x divided by 4 is equal to 20. Well, in this question, I have x divided by 4 is equal to 20, so I'll have to multiply both things by 4 over 1. So when I multiply fractions, the top gets multiplied by the top and the bottom gets multiplied by the bottom. So 4x over 4 is equal to 20 times 4 is 80. And then 4x is divided by 4. Well, they'll cancel the 4's and I'll get x is equal to 80. So now I have to check my answer, just like before. So I have x over 4 is equal to 20. Then I'll have 80 divided by 4 is equal to 20. And 80 divided by 4 gives me 20, so 20 is equal to 20. So I know that's true, so I've solved the equation correctly. That is our review done of the work we did yesterday. In today's lesson, we're going to be looking at, very specifically, solving linear equations in one variable with more than one operation and with one variable on either side of the equal sign. There are two objectives for the day. Now, the next type of equations we're going to solve are ones that are going to require multiple operations. The ones we did yesterday only needed addition and subtraction, or they only needed multiplication and division. These ones are a little bit more complicated in that they're going to need us to use more than just one operation in them. So I've taken the first one here as an example. So that has 20a minus 11 is equal to 149. So when I look at this question, first off, I have 20 a's, and I want them on the left-hand side of the equation. I have a minus 11, which I don't want on the left-hand side of the equation, and I have a 149, which I do want on the right-hand side. So if I want to make a slight adjustment here, I'll add 11 to both sides of the equation. Once I add 11 to both sides of the equation, I'll be left with a 20a minus 11 plus 11 will give me 0. And 149 plus 11 will give me 160. Now, the line we have here is just like questions we were doing yesterday. So now we know that we have 20 a's, and 20 a's are equal to 160. If I want to find out what 1a is, I'll have to divide by the number in front of a, the coefficient of a. So I'm dividing 20a by 20. But in order for me to be able to do that, I'll have to divide the other side of the equation by 20 as well. So 20a gets divided by 20, and that leaves me with a. And 160 gets divided by 20, and that leaves me with 8. So my answer for this question is a is equal to 8. Now I can check my answer for this, the same as before. And the way I check is I'll have 20a minus 11 is equal to 149, and I'm going to substitute in 8 for a. So I have 20 times 8 minus 11 is equal to 149. 28s, well, 2 8s are 16, then I'll have to add a 0, bring me to 160 minus 11 is equal to 149. Then I'll have 149 is equal to 149. So I know I've solved this question correctly. Now, my next question, let me think, should I pick a harder one? Well, I think 20 probably is the hardest one available, so we'll go for it. So, we begin again, and we say, okay, well, I have a 36n on the left-hand side of this equation. I have a negative 31, which I would rather not have on the left-hand side of the equation. And I have a 149, which is fine to have on the right-hand side of the equation. So, what I'll want to do again is I want to add 31 to both sides. And once I add 31 to both sides, I'll be left with 36n minus 31 plus 31, will leave me with nothing, is equal to 149 plus 131. So that will be 150 and 180. So then I have, 36n is equal to 180. And then what I will do is I will take that 36n, divide it by 36, take the 180 and divide it by 36, and I'll find out what n is equal to. Now, 180 divided by 36, you can use your calculator if you want, but I would know that there's 10 36s in 360, and I know that 180 is half of that, so that means that n will be equal to 5. So if I multiply 5 by 36, I get 180. So n is equal to 5. And again, I can check my answer for this. So I check the answer by substituting in. So I have 36 times n minus 31 is equal to 149. 36 times 5 minus 31 is equal to 149. 36 times 5 is 180. Minus 31 is equal to 149. And then I'll end up with 149 is equal to 149. And that is that question done and dusted. Now, before you jump into doing any of the questions, what I want you to do is I want you to pause the video and try and do both those questions without looking at the video. Then once you're happy you can do that, then you can get started on solving these equations, which are here under 12.4, multiple operation equations. The next type of questions we have are equations where we have a variable on both sides of the equation. So that means in this case, if we look at this very first equation that I've done out here, we have 5a on the left-hand side of the equal sign, and we have a minus 4a on the right-hand side of the equal sign. That's what makes these questions a little bit different, okay? So, as before, I want all the variables on the left-hand side of the equals and all the numbers on the right-hand side of the equals, all the constants on the right-hand side. So first off, I'm going to set out to get the variables on the left-hand side for myself. So I have 5a minus 9 is equal to 54 minus 4a. Now, if I want to move that 4a to the other side, I'll have to add a 4a to this side and add a 4a to that side. When I do that, I'll be left with a 5a plus 4a minus 9 is equal to 54. Because the minus 4a and the plus 4a here will cancel each other out. Now I'll be left with 9a's minus 9 is equal to 54. Now once we're at this line, this question is the exact same as the ones we've just done previously. So next up, what we want to do is we want to get that negative 9 onto the other side of the equation. How we can do that is by adding a 9 to both sides of the equation. So what we'll do is we can add a 9 here and add a 9 here. Once I've done that, I'll be left with 9a is equal to 63. And once I'm this far, I can see if I have 9a's and 9 of them are equal to 63, I'll divide by 9 to find out what it would be if I only had 1. So 9a divided by 9, well, that'll leave me with a by itself. And 63 divided by 9, well, 9 sevens are 63, so that will leave me with 7. Now, same as before, I can check my answer by substituting. So I'll check my answer by substituting, so that involves going 5 times 7 minus 9 is equal to 54 minus 4 times 7. Oh, and I'm after squeezing that in a little bit. So now I have 5 sevens are 35, take away 9 is equal to 54, minus 4 times 7 is minus 28, so 35 minus 9 will leave me at 46. Oh wait, no it won't, that'll leave me at 26, my bad. And 54 minus 28 will also leave me at 26, so that's true, so I know that's done and dusted, happy out. Then the next question up. Same process again. So I start off, I want my R's on one side and I want my letters or numbers on the other. So first off, I'll have to add 4R to both sides because I want to move that to the other side. Then I'll have 10R plus 9 is equal to 29. Because again, these two cancel each other out, and 4R and 6R will give me 10R's altogether. Then I have 10R plus 9. I want to take 9 away. 29, take away 9. Now I'm left with 10R is equal to 20. Because again, these two cancel each other out. 29 minus 9 leaves me with 20. So I have 10R's is equal to 20. 10R's divided by 2. 20 divided by 2. That leaves me with R is equal to 2. And again, if I want to, I can check my answer same as before. but I'll not make the video any longer. So same as before, I'd be suggesting if you guys can try and do question 1 and question 20 by yourselves without looking at the work I've done, and then check it against the work I've done in the video. Then once you have that done, you can get started into the questions 1 to 20 here on the tab. So this is the 12.5 tab inside Algebra 2 in your OneNote. So just go down from school closure down to content library, Algebra 2, and all the questions for the first section and the second section are here.